given A is equal to this matrix satisfies the equation a cube minus a square minus 3a minus I3. Find A inverse. So given A is equal to satisfies what equation? Satisfies a cube minus a square minus 3a minus I3 is equal to 0. So A satisfies this equation. You need to find A inverse. Okay. So first let us see whether inverse exists. Let us find det A first. Here det A is equal to so here again if you want to expand this determinant plus minus plus position. Okay, so this is 1 and the minor of 1 is and this is plus of minus 2 times minor minus 2. See the one with 0, that minor vanishes. That is why I'm not writing that.
Okay, sir.
1 minus 1 minus 8 minus 2 into minus 8 plus 3. Okay, so how much does it come to? Minus 9 minus 2 into minus 5 minus 9 plus 10 is 1, not equal to 0. So therefore A is a non-singular matrix. A is a non-singular matrix. Therefore A inverse exists. Okay, now since A inverse exists, now what we'll do is we'll use this relation. Okay, we'll use this relation to find out the inverse. So we have a cube minus a square minus 3a minus I3 equal to 0. Okay, and now see, do you know what to do after this?
Yes, sir.
Do you know what to do after this? Break up a cube
Yes,
as
sir.
a into a square minus
Yes,
break
sir.
up a
Yes, sir.
square as a into a minus 3a minus I3 to 0. Now what you do is
Yes, sir.
pre-multiplying both sides by a inverse. Pre-multiplying both sides by a inverse. So what do you get? A inverse a into a square minus inverse a minus. Can I write directly or should I do step by step?
Right, directly.
Directly. Okay.
Sir, you can write directly.
Okay.
Yes, sir.
Inverse a minus thrice inverse a minus inverse I3 is equal to 0. So a inverse a is I3 in fact, I3 a square minus this is I3 a minus thrice I3 minus A inverse is equal to 0. So therefore, you get A square. I3 into A square is simply A square. I3 into A is A minus A inverse. So A inverse here is A square minus A minus thrice I3. Okay, so this is what your A inverse is. If we simply find this, then we'll be able to find A inverse. No need to find your adjoint of A. Okay, so let us proceed to find A square. Here, A square is equal to A into A. And let's see what the matrix A is. Matrix A is 1, 0, minus 2. Minus 2, minus 1, 2. And 3, 4, 1
341.
with the same. And you multiply. Okay, so this is 1. First row, first column. 1 plus 0 minus 6. So it is 1 plus 0 minus 6. Okay. Next, first row, second column. So 1 into 0 is 0 plus 0 into minus 1 is 0 plus minus 8. So 0, 0 minus 8. First row, third column, minus 2 plus 0 minus 2. Okay. Next, second row, first column, minus 2, and then you have plus 2, and then you have a plus 6. Second row, second column, 0 plus 1 plus 8. Second row, third column, 4 minus 2 plus 2. This you have 3 minus 8 plus 3. Here you have 0 minus 4, 0 minus 4 plus 4. Isn't it? 0 minus 4 and plus 4. Yes. So this is next last is third row, third column, minus 6 plus 8 plus 1 plus 1. So this is 1 minus 6 is minus 5. It's minus 8. This is minus 4. This is 8 minus 2 is 6. This is 9. 6 minus 2 is 4. And this is 6 minus 8 is minus 2. And this is 0. And this is 7 minus 6, 1. Right? So A square we have found out. Now we can find A inverse. Hence, what is A inverse? Hence, A inverse is equal to what had we got? A square minus A minus thrice I3.
Sir, it will be 3, no?
Which one?
Yes, sir.
Sir,
Tell me which one.
Sir, third row, third column. Instead of a 1, it will be 3.
3. 9 minus 6, 3. Yes.
Third row, third column.
Okay, so A inverse, we put the value of A square here. Minus 5, minus 8, minus 4, 6, 9, 4, minus 2, 0, 3, minus A. What is the matrix A? 1, 0, minus 2. Next, minus 2, minus 1, 2. And 3, 4, 1. Mm. Minus thrice I3. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. This is minus 5, minus 8, minus 4, 6, 9, 4, minus 2, 0, 3, minus 1, 0, 2, minus 2, minus 1, 2, 3, 4, 1, minus 3, 0, 0, 0, 3, 0, 0, 0, 3. Okay.
Sir, first row, third column, it will be minus 2.
Which one first row? Oh, this one, 1, 0, minus 2. So let us now minus 5, minus 1, minus 3. Okay, minus 8, minus 0, minus 0. And then you have minus 4 plus 2, minus 0. Then you have 6 plus 2, minus 0. Then you have 9 plus 1, minus 3. Okay, and then you have 4 minus 2 plus 0. Okay, minus 0, whatever. Okay, let me write a minus. So you have 4 minus 2 plus 0. And this is minus 2, minus 3, minus 0. Now 0, minus 4, minus 0. 3, minus 1, minus 3. Minus 9, minus 8, minus 2. 8, 7, 4 minus 2 is 2. Minus 5, minus 4, and minus 1. That's okay. This is your A inverse. Okay. If you want to check whether you have got the right answer, what you can do is you can multiply A and A inverse, check whether you're getting the identity matrix. Okay. Clear?
Yes, sir.
Let us do the next one. Maybe one more. I don't have time for much.
Yes, sir.
You can do number 23 on your own. Show that A is equal to, this is a 2 by 2 matrix, satisfies this equation. X cube plus 4x minus 42. Find A inverse.
Yes.
Can you do this? Let me just give you hints. Okay, it's the same as this, the one that I did. Since A satisfies this equation, therefore A cube minus plus 4A minus 42 is equal to 0, isn't it? Since A satisfies this equation, therefore if you put A in place of X, you must get this. So now from here, can you find A inverse? Just
Yes,
as we
sir.
did here. Okay. So that is what you need to do here. This is a
Yes,
2
sir.
by 2 matrix. So do this sum also. Okay. For practice sums. One more sum I have given you, isn't it, earlier? Which sum did I give you?
Yes, sir. Yes, sir.
I gave you this one. 14 2. So do 14 2.
Yes, sir.
Do 23 as a practice sum. Okay. And 27 type I have shown you, right? This type I have shown you. Remember that orthogonal matrix? Remember orthogonal matrix?
Yes, sir. Yes, sir.
Uh,
Orthogonal. Yes, sir. You have
uh,
shown.
Actually, this matrix is orthogonal. That is why A inverse is equal to A transpose. Okay. You don't have to show that it is orthogonal. Okay. Here you only have to show that A inverse is equal to A transpose. You find out A transpose and then you find out A inverse and to show that they are equal. That is what you have to do. There's no concept of orthogonal here. But what you can see from this property is that this matrix has
Orthogonal.
to be an orthogonal matrix. Okay. So this
Okay,
is an
sir.
indirect. They have not mentioned orthogonal, but that is what they intend to convey.
Okay, sir.
If A is equal to where omega is the imaginary cube of root of unity, this one I'll do. Complex numbers, 28.
Okay, sir.
Yes.
We have not done complex number for a very long time. Let us do one sum from matrix and complex numbers,
Okay,
combination
sir.
of both. Now see here, if A is equal to, given A is equal to 1 omega omega square, omega omega square 1, omega square 1 omega, where omega is the cube root of unity.
Yes, sir.
Now if you remember from your class 11 knowledge, if omega is the cube root of unity, then these two relations hold. Omega cube must be equal to 1, and what else? 1 plus omega square must be equal to 0, right? These two must hold. If you remember from your class 11 knowledge, do you remember or not? Or have you forgotten?
Yes, sir.
Yes, sir. Yes, sir.
And now we'll find the
Yes, sir.
inverse of A.
Remember.
So let's first find det A. Let's check whether A is singular or non-singular. Det A is 1 omega omega square omega omega square 1 omega square 1 omega. So let's see what this value comes to. This is a plus minus plus. So 1 into omega square 1 1 omega minus omega omega 1 omega square omega plus omega square omega omega square omega square 1. Okay. Tomorrow I'm going to start your matrix inversion. I mean, solution of a system of equations by matrix inversion method. Okay. So that will almost complete the
Okay,
chapter
sir.
on matrices, except that you will have
Okay, sir.
elementary operations remaining. So that I will think I'll finish very soon. I don't have it actually on my textbook, that this elementary operations, but you must be having because you have the new edition. I have the old edition. Fine, but still I'll cover 3 or 4 problems so that you understand. You'll be able to do on your own. So here you have omega cube minus 1. If you expand this determinant, minus this, you have omega into omega square minus omega square plus omega square, and this you have omega minus omega to the power of 4, isn't it? So omega cube minus 1. Omega cube is 1. So
Yes, sir.
1 minus 1 you put. Okay. You know omega cube is equal to 1 minus this is 0
Yes, sir.
plus
Yes,
omega
sir.
square omega minus omega to the power of 4. What you do is you write this as omega cube into omega. Okay. So you get
Yes, sir. Omega cube into omega
1
equal
minus
to
1 minus 0. Okay. Then you have plus omega square. Again, omega cube
sir.
is
It will be omega. Yes, yes, sir.
1. So this is 0 minus 0 plus 0. 0. So A is actually a singular matrix. Therefore, A inverse does not exist.
Yes, sir.
A is a singular matrix. Therefore, A inverse does not exist. Okay. Then why have they given this question? See number 28 answer. Yes, this one. See omega det A is equal to 0. Therefore, it does not exist. You see.
Yes,
Yes,
sir.
sir.
So it does not exist. That is your
Yes,
answer.
sir.
So I think I'll finish off here. No more required. No more problems.